Welcome to SSR Pharma Media, your trusted source for pharma knowledge. PIC MCQ series, your exam power boost. Pharmaceutical Inorganic Chemistry. Today we are going to discuss about acid-base titration. Prepare, practice, succeed. So in acid-base titration, so these are all the topic going to cover. Today we are going to cover only these three topics. So acid-base theories and theories of acid-base indicators, classification of acid-base titrations, preparation and standardization of titrant like hydrochloric acid and sodium hydroxide, theory involved in titration of strong, weak and very weak acids and bases, and finally neutralization curve. So in acid-base titration theories and theories of acid-base indicator, we are going to discuss now. So acid-base indicators there are three types: Arrhenius theory, Bronsted-Lowry theory, Lewis theory. And Oswald theory. This is the type of acid. What is acid and base? This is the acid-base theory. And theories of acid-base indicators are Oswald theory, Funanoid theory, and adsorption theory. So Arrhenius theory. According to Arrhenius, acid is defined as it produces hydrogen ions in aqueous solution. But base means it's produce OH ions in aqueous solution. So in acid-base reaction depends upon the ion formation in water, and it is limited to aqueous system only, according to Arrhenius theory. For example, when HCl dissociate hydrogen ion in water and sodium hydroxide dissociate OH minus ion in water. And Bronsted-Lowry theory, according to his, so acid is defined as proton donor and base is defined as proton acceptor. So it is a neutralization reactions takes place in the neutralization reactions and proton transfer. Includes conjugate acids and base pair. Due to this proton donor and acceptor, it produces conjugate acid and base pairs. For example, HCl donate hydrogen ion and it ammonia accept hydrogen ion and it form ammonium. So it's a acid and it's a base, conjugated acid and base used to form. According to Lewis theory, electron pair acceptor. So acid is defined as electron pair acceptor, base means electron pair donor. And during this acid base reaction, so the reaction happens in the coordinate covalent bond. And in applicability, most general theory covers non-protonic acids. And for example, BF3 acid when react with the acids and fluoric acids and boron acids plus NH3 ammonia react to form the complex. So these three are scientists. Finally, Lewis. So Arrhenius theory, Bronsted theory and Lewis theory. These three scientists are telling what is acid and what is base. And during the reactions between acids and water, what product may form. And remaining these three are its type of acid-base indicators: Oswald theory, Funanoid theory, and adsorption theory. So according to Oswald theory, so indicators are weak acids producing colored form. Indicators ionize to basic colored form and color change due to ionization equilibrium. So in this indicator, when ionization produce H plus ion and product. So this produce the color changes. And explain how working of most acids and base indicators. So example, methyl orange, bromothiamyl blue. Quinonide theory. So its acid form benzonide structure and base form quinonide structure. Color depends on structural tautomerism. So applies mainly synthetic organic indicator. So example, phenolphthalein. And adsorption theory, indicator anions adsorb to precipitate, indicator cations adsorbs, and color change due to surface adsorption. Used in precipitation titration. Example, fluorescent indicator in Ag plus ion titration. In Arrhenius theory, which limitation is correct? So option C is answer, limited to aqueous media only. According to Arrhenius theory, which of the following is a base? So option B is the answer, sodium hydroxide. A Bronsted-Lowry base must, option D, accept a proton. Bronsted-Lowry conjugated base of H2SO4 is, option C, HSO4 minus is a conjugate base. So after donating hydrogen ion, it becomes base, conjugate base. In a titration of acetic acid with NaOH, the Bronsted-Lowry base is, option B, acetate ion. Which of the following act as a Lewis acid in solution? So option C, so BF3. So electron pair acceptor and electron deficient BF3. So accept lone pair of NH3. Which reaction best represent a Lewis acid base interaction? So option C, so reaction. In Oswald theory, indicator color change occurs due to, so option C, ionization equilibrium of weak acids and base indicator. According to quinonide theory, the acid form of indicator has, option B, benzonide structure. Which indicator is best explained by quinonide theory? So option C, phenolphthalein. The indicator color change in Oswald theory occur at, so when ionized and unionized, option C is the correct answer. Ionized and unionized indicator ratio change with pH. According to Oswald theory, acid-base indicators are weak organic acids and base that ionize slightly. In quinonide theory, the color change of indicator is due to, option C, conversion between benzonide and quinonide forms. Which of the following best describes the Oswald indicator theory? Option B, change in ionization state. Which indicator is best explained by Oswald theory of ionization? So option C, methyl orange. Quinonide theory applies primarily to, so option B, indicators capable of tautomerism. A good indicator must have, option B, short, narrow pH range. Indicator color change occurs at, option B, endpoint. So in classification of acid-base titration, so acid-base titrations are classified into several types. In the first, strong acid versus strong base, strong acid versus weak base, weak acid versus strong base, weak acid versus weak base, very weak acid titrations. So in this strong acid versus strong base, hydrochloric acid, nitric acid, sulfuric acids are example of strong acids, and weak base example sodium hydroxide, strong base example sodium hydroxide and potassium hydroxide, and neutralization occurs at 0.7. So all reaction neutralization point of nearly 7, and key So in this strong acid versus strong base, sharp and steep pH jump, most reliable titration type. Say indicators are used: phenolphthalein, methyl orange, bromo, thymol blue. In strong acid versus weak base, so weak base example ammonium hydroxide and aniline. So slightly acidic pH endpoint may occur and weaker pH jump and conjugate acid form acidic salt. And methyl orange, methyl red is the best indicator. In weak acids and strong base, so weak acid is example acetic acid and formic acid, and basic pH equivalence point may occur. So example phenolphthalein is the indicator. And weak acid versus weak base, acetic acid, boric acid is example of weak acid, weak base ammonium hydroxide, and here there is no sharp endpoint may not occur and no suitable single indicator. So for this mixed type of indicators may used. So or otherwise this type of titration referred to the back titration. And very weak acid titrations. So weak acid, boric acid and carbonic acid, strong base sodium hydroxide, and depends upon the complexation the endpoint may occur. So indicator is phenolphthalein. So this is another type, polyprotic acid titration and non-aqueous acid base titration and back titration. So polyprotic phosphoric acid and carbonic acid are example of polyprotic acid, and base strong base of sodium hydroxide and potassium hydroxide. Here the indicator is used phenolphthalein and methyl red. And non-aqueous acid base titrations, so it is mainly used for the titration of weak base in glacial acetic acid and weak strong acid like perchloric acid in non-aqueous medium like glacial acetic acid. And indicator is crystal violet and methyl orange. And back titration, weak acids and weak base when slow reacting samples may use taken for the back titration. Here the excess standard acids or base are added into the conical flask. So after the completion reactions, the unreacted excess acid may titrated with the burette solutions and the endpoint may occur. So here this indicator is mixed type of indicators may used, depends on the second titration types. In which titration type is the pH at the equivalence point approximately 7. So option C, strong acid versus strong base. The best indicator for titrating a weak acid with a strong base is, so option B, phenolphthalein. Which of the following titration types show no sharp equivalence point? So the answer is option C, weak acid versus weak base. Boric acid requires a complexing agent during titration because, option C, it behaves as a very weak acid. Which titration is best performed in non-aqueous medium? So option C, weak organic base versus perchloric acid. Which titration type shows multiple equivalence point? Option B, polyprotic acid titration. For strong acid versus weak base titration, the equivalence point is, so option C, acidic. In which case is back titration preferred? So option C, strong acid versus weak base. Which among the following pairs gives the sharpest and most reliable titration curve? So option D, HCl versus NaOH, because both are strong. Which indicator is most suitable for strong acid versus weak base titration? So option B, methyl orange. Which of the following is the pH range for phenolphthalein? So option C, 8.2 to 10 is the pH range of phenolphthalein. Methyl orange is suitable for titrating. Option C, strong acid versus weak base. Acetic acid is titrated with NaOH is, so option B, weak acid versus strong base. Ammonia treated with HCl is, so option B, weak acid with strong acid. Weak base with strong acid. pH at equivalence point for strong acids and strong base is, option A, 7. pH at equivalence point of weak acids and strong base titration is, option C, less than 7. That means more than 7. Choice of indicator in weak acids and strong base titration depends on, option C is answer, pH at equivalence point. Titration of HCl with NaOH belongs to, so answer in comment box. So all of you join in our WhatsApp community. You will get hands-out material and number of test series. Thank you. Like, subscribe and share. So thank you.